Hello everyone. I am Mrs. Hema Sagar Kumbar, working as Assistant Professor in Department of Computer Engineering, PIST Pune. In this video, we are going to discuss another form of normalization, that is Boyce-Codd Normal Form, which is also called as a BCNF. Now let's look at the conditions set by the Boyce-Codd Normal Form. The very first is it has to be in the 3NF. It has to follow the 3NF criteria. Second one, every non-trivial functional dependency x arrow y. X must be a super key. So in other words, we can say that the Boyce-Codd normal form is the extension of the 3NF. So to be in the Boyce-Codd normal form, the relation has to first satisfy the 3NF criteria, which says that there should not be any transitive dependency. And the another criteria has to be follows that for every functional dependency of type x arrow y, x should be always a super key. So this means that for every dependency, a determinant x must uniquely identifies every attribute in the relation. So simpler we can say that the functional dependencies present in that particular relation, for every functional dependency, determinant should be always a super key. Let us look at the example of this. I do have one relation called as enrollment, wherein I do have three attributes: student ID, course name and the professor, and these are the values present in this. The functional dependency present in this relation are student ID course name identifies professor and professor identifies the course name. The primary key is student ID and course name, and there is one more primary key also, student ID and professor. So is it in 3NF? Yes, because there is no any presence of the transitive dependency. But this violates the rule of the BCNF. How? Because BCNF says that for every dependency x arrow y, x should be always a super key. But in this case, because of this functional dependency professor arrow course name, professor is not my super key. My super key attributes are student ID and course name only. So to be in the BCNF, every functional dependency for this example, there should be a functional dependency determined by the student ID and course name only. So hence we have to eliminate this to be in the BCNF. So we'll follow the same rule that we have discussed in previous few videos, that the decomposition, we have to identify the closure of the attributes which violates the rule. So professor arrow course name is the functional dependency which violates the rule. So as in, I will identify the professor closure and the course name closure. R1 is my professor closure and R2 is whole relation minus the course name closure, which is student ID and course name. So this is the possible decomposition of this relation to be in the BCNF, so that it will not have any kind of trivial functional dependency. And every functional dependency which is of the form which will be determined by the super keys. After decomposition, this is my table. So first table is professor course, which is named as a professor course with the attributes as professor and course name, and second, which is named as a student enrollment with the student ID and course name. Over here you can say that the professor is a primary key of this, and student ID is the primary key of the second relation. And this is a complete decomposition of this example to be in the BCNF. Thank you. See you in the next video.